Okay, today we are going to learn one of the most important topics in algebra, which is called the quadratic formula. So this is section 9.1.2, Intro to the Quadratic Formula. The notes sheet says, in the previous lesson, we developed methods to solve quadratic equations. Today we are going to learn a new method to solve quadratic equations, and I'm just going to dive right in and say that this method can be used to solve any quadratic equation that there is. So first we are going to warm up, and it says a quadratic equation can be written in perfect square form, and you guys know that. We've been drilling that the past 2 lessons. We can complete the square in order to get it into this perfect square form. So notice that we used to use graphing form to describe quadratics in this form, but now when C is a number, we are not going to call it graphing form, we are going to call it perfect square form. So if you look through A, B, C, and D, all of these problems are indeed in perfect square form. But the instructions say to write the following equation in perfect square form, and then our goal is to determine the number of solutions for each quadratic. We don't actually have to give what those solutions are. So we are determining the number of solutions. So go ahead and pause the video if you recall from yesterday's lesson how we complete the square to look at the solutions to each equation. If not, keep me rolling and work with me. So we have to go ahead and get this in perfect square form. So we have 3 equals, leave a blank, set up our square, and then we are going to place our x squared. We are going to divide our negative 6x by 2 to get negative 3x and negative 3x. I'm bad with my 3's on this iPad. And then we see that we have 10 units, but we want 9 because negative 3 times negative 3 is 9. And remember, our dimensions are always defined when we place our x squared in our x tiles. So what do we need to add to 10 to get 9? We have to add negative 1. So we have to add negative 1 to this side as well. So what is our perfect square form? Our perfect square form is 2 equals quantity x minus 3 squared. Now at this point, if we were to imagine solving this equation, what would we do? We would go ahead and undo the square by square rooting. And so we would see that we have plus or minus the square root of 2 equals x minus 3. Now going back to the question, it says the number of solutions. So how many solutions are going to result? We see that we are going to have 2 solutions because of the plus or minus. So this quadratic equation is going to have 2 values of x that will make it true. Now, if we go to the next problem, let's change the color here. We look at, a standard form, m squared plus 12m plus 37. So we have our 0 this time, leave a space, make our square to get it in perfect square form. We have m squared, and then we have 12m divided by 2 is going to be 6m and 6m. So now I have m plus 6 and m plus 6. And so I have 37 units, but what do I really want? 6 times 6 is 36. So what do I have to do to 37 to get to 36? I have to subtract 1 from both sides. So I have negative 1 equals the quantity m plus 6 squared. Now again, thinking about solving this, what am I going to do next? I'm going to square root both sides. But what is going to happen? If we take the square root of negative 1, like you see right here, what are we going to get? If you go ahead and do that in your calculator, we see that it would say domain error or something along those lines. So when we square root a negative, that is going to result in no solution. So the first problem that we did had 2 solutions. Now in this case, we have 0 solutions. And why did that occur? Because we cannot square root negative numbers. So that's very important. Moving right along to question C. Okay, we have our units all over to one side, but that's okay. I want to show you how you can work through this type of a problem. So we have negative 81, leave a space, and let's go ahead and make our square. And we have 4p squared. We're going to have to be careful with that. 4p squared. And then we have 36p. So what do we have to do to that 36? We have to divide it by 2 to get 18p and 18p. And how many units do we currently have? We have 0 on that side with the expression. So our dimensions are not going to be p and p, okay? It's going to be 2p because we have to figure out the same identical dimension for the lower left-hand box. And then we have, okay, 18, or sorry, not 18. What do we need? We're going to have 9 because 2 times 9 gets us 18p, and then we're going to have 9 in this box. So now this is kind of a challenging square because we've always been used to our leading term being a 1. So from this point, we need to think about, okay, 9 times 9 is 81, so how do I get from 0 to 81? I have to add 81. So if I add 81 to this side and I add 81 to this side, okay, negative 81 plus 81 is 0, and I have equals 2p plus 9 squared. Well, if I go ahead and continue on and take the square root of both sides, I always know that I'm going to put a plus or minus out front, but what's the square root of 0? It's 0 equals 2p plus 9. Now, what's positive 0 or positive 1 times 0 or negative 1 times 0? In both cases, our mini equations are going to be 2p plus 9 equals 0 because plus or minus 0 is just one value. So how many solutions are there going to be? There is going to be one solution in this case. And what controls that? This right here. Okay, hopefully you're catching on to something. This controlled the fact that there were two solutions. We see that the square root of negative 1 controlled that there were no solutions. The square root of 0 controlled that there were one solution. So let's move on to this last one, okay, and take a look. So we have 0 as our unit term, leave a space. We have our square, and we go ahead and yay, k doesn't have a number in front of it, so we're back to normal there. And let's divide negative 3 by 2. So what are we going to get? Negative 1.5k. So this is going to be negative 1.5k. Yikes. We can still keep going though. So we have k minus 1.5. We have k minus 1.5. Now what do we have to do with these unit dimensions? We have to multiply them together. So 1.5 times 1.5 is 2.25 because a negative times a negative makes a positive. So we're thinking about how do we get from 9 to 2.25? Well, the shortcut, we see that we're getting smaller, so we can go ahead and take 9 minus 2.25 and see that we have to subtract 6.75 from both sides. So when I take 0 minus 6.75, I now have negative 6.75 equals k minus 1.5 quantity squared. Now to solve this, what are we going to have to do? We are going to have to root each side, and we see that when we take the square root of a negative, that is going to result in how many solutions? It is going to result in 0 solutions. The answer is not 0. It means that there is no solution, but I wanted to write it like this because it did say how many. So that is the same thing as no solution. So, from our warm-up, we want to quickly explain how we can quickly determine the number of solutions that a quadratic equation has once it is written in perfect square form. So remember that perfect square form is at the top of our notes, ax plus b quantity squared equals c. So let's go ahead and write that down again for consistency. So we have learned, yes, this is very similar to graphing form. We use completing the square, but perfect square form is ax squared, no, that's standard form. It is the quantity ax plus b squared equals c. So how are we going to know how many solutions something that is in this form has? Well, if c is greater than 0, meaning if c is positive, then we know that there are going to be 2 solutions, and that is like part A that we did above. Now, if c is equal to 0, okay, if we scroll up and look at equation c, then we notice that there is going to just be one solution, and that is because plus or minus 0 just gives you one quantity. And finally, if c is less than 0, that means if the unit term is negative, then there are going to be 0 solutions, no solution, because you cannot square root a negative. Okay, so this was an excellent warm-up to drill completing the square and also dive into perfect square form when it's an equation rather than a function. Now for the big drum roll and learning the quadratic formula. Okay, this is something that you will use in geometry, algebra 2 and beyond, because this can solve any quadratic that you're given. So I'll read, follow along with me. It says one way to calculate the roots. What does roots mean? X-intercepts. So one way to calculate the x-intercepts of a parabola is by using the quadratic formula. So you want to write quadratic formula in your notes. This formula uses values a, b, and c from a quadratic equation that is written in standard form. And we'll look at that in the next paragraph. So the formula that you need to write down right now is in this green box here. The quadratic formula is x equals negative b plus or minus the square root of the quantity b squared minus 4ac, everything over 2a. Now I've attached a link to a silly song that you'll want to watch after this video because you need to memorize exactly what I just said. Now if we memorize it to the lyrics of a song, trust me, it is a lot easier to stick. So how are we going to apply this? So let me emphasize that this formula is used to find the x-intercepts of a quadratic equation. Now, what does that really mean? When a quadratic equation is set equal to 0, so when y is 0, we can use this method. And I'll show you some shortcuts as to how to always create an equation that has y equaling 0. How do we use it? Okay, the first thing is we have to be in standard form. So you have to make sure that your equation is in standard form. If it is not in standard form, then you need to get it in standard form before you do anything else. So if you don't know what standard form is, we need to finally catch on to that. It's ax squared plus bx plus c equals 0. Okay, now this is important. You have to have it equal to 0. So if there is a different number there, you have to move it to the other side. If it is written in this form, then our a, b, and c are just right in front of our eyes in order. A is the number, the coefficient on x squared. Okay, B is the number that is attached to the x, and C is the unit term that has no variable. So if we are looking at this equation right here, x squared minus 3x minus 7, in this case, A is 1, because what is out front of the x squared if it is not written as a number? It is 1. Okay, what is our B? What number is attached to the x? It is negative 3. You have to carry that negative that is right in front of the 3. And then what is our C? It's similar to what we just did. It's not 7, it is negative 7. This is always the first step that you have to establish before you utilize the formula boxed in green. So now we are going to use these three numbers, 1, negative 3, and 7, and we are going to plug them in to this formula. We are going to do order of operations, and then that will give us the values of those x-intercepts. In other words, will allow us to solve a quadratic equation. So part B says the quadratic formula calculates two possible answers by using the plus or minus symbol. This symbol, read as plus or minus, is shorthand notation that tells you to calculate the formula twice, which is not shocking because how many solutions do we usually get from a quadratic equation? We get 2. Once with addition, once with subtraction in the numerator. Therefore, every quadratic formula problem is really two different problems, unless, of course, the value is 0. Okay, so if you see that b squared minus 4ac after you take the square root is 0, we've established in the warm-up that plus or minus 0 really just results in 0. So that would represent just one solution because adding 0, subtracting 0 doesn't change the value. Okay, so now at this point, this is your first time to write out the quadratic formula. I'm going to continually say it, and you need to either memorize it by song or memorize it in whatever way works for you. So when we're solving a quadratic equation, x equals the opposite of b. Now, negative in math means opposite, plus or minus the square root of, watch how I write it, b squared minus 4 times a times c is all underneath the square root, and then the entire right-hand side is over the quantity 2 times a. This is what you have to memorize, okay? So that needs to be in your head when we get back to school. So every day you need to work through that. So now we are going to apply it. It is very procedural, very robotic, sometimes I say to you guys. So what we want to do is we're still working with this same quadratic equation. And if you recall, our A was 1, our B was negative 3, and our C was negative 7. When we use the quadratic formula, we only plug in numbers. We do not plug in variables. That's a common mistake that I see. So we want to go ahead and plug it into the quadratic formula. What is the formula? I'm going to do it again. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the first step of the quadratic formula, step 1, is to plug in values. Okay, so let's go ahead and plug in our values. So we have x equals, what is the opposite of negative 3, or what is negative 3? It's positive 3, plus or minus the square root of. Always put b in parentheses, because what happens when we square a negative? If we don't put it in parentheses, our calculator doesn't give us the right value. Minus 4 times my A is 1 times my C is 7. Sorry, good thing I caught this. It should be negative 7. Make sure to make that correction on your paper. All over 2 times 1. So that is our first step. From here then, okay, the second step is to simplify under the square root. So step 2, is to simplify under the root. So we are going to go ahead and rewrite x equals 3 plus or minus the square root of. Now what I'm going to do is negative 3 squared. Okay, this leading term will never end up being negative because when you square a number, it's always positive. Now what I am going to do is I am going to look at my negative 4 times 1 times negative 7 as a 3-term multiplication problem. I am grouping the negative with the 4. So I'm asking myself, what is negative 4 times 1 times negative 7? Well, negative 4 times 1 is negative 4, and then negative 4 times negative 7 is positive, now look how I'm writing it, 28. If when I multiplied the 3 numbers, including the negative on the 4, I got a negative, I would write negative instead of the plus sign. And then 2 times 1 is 2. We can go ahead and do that as well. Now we have to continue to simplify under the square root. So this is still step 2. So 3 plus or minus the square root. 9 plus 28 is going to give us 37 over 2. Okay, now these order of operations matter. You can't choose to, for instance, now divide 37 by 2. Because at this point, we see that we cannot square root 37 to get it's not a perfect square number, I should say. It's irrational. So at this point, we have found our exact solution. Okay, it's even kind of messier than when we had perfect square form. So this is the exact solution. Now we are going to type it into our calculators because we see too many equations out of this. We see that x is 3 plus the square root of 37 over 2. And we see that x is 3 minus the square root of 37 over 2. So this is 2 calculations, and please calculate this with me because it's amazing how many people type it in wrong. What I would suggest is you go ahead and type in the numerator on your calculator, press enter. Then press divide by 2. Okay, so when you do 3 plus the square root of 37 and press enter, you're going to see a decimal of 9.0827. Okay, do not do anything with that. You are then going to just press the division bar, so then it carries down your answer without rounding, divide by 2, and you should get approximately 4.54 when you round to the nearest hundredth. And then when we go to the second equation, we can go ahead and do 3 minus the square root of 37, and you should get negative 3.0827, press divided by 2, and you should get negative 1.54. Okay, I'm serious when I say that so many people get the right answer with their exact, and then they can't get the approximate because they type it into the calculator wrong. So go ahead and circle this to see that this is the approximate answer. Okay. Whoops. And that is how you use the quadratic formula. So it's very procedural, but you have to remember the formula, or else it does you no good. So from here, we can make a graph of the original equation, and we can think about where are we going to look to verify our solution. Okay, well, when you use the quadratic formula, remember, it has to be in standard form, and it has to be set equal to 0. So that really means that every time we use the quadratic formula, y has to be 0. So where is y 0? On those x-intercepts. So when we check our answer to something that we have used for the quadratic formula, we are always going to look at x-intercepts, which is different from what we did yesterday when sometimes there was a number other than 0 in place where y would be. So if we go ahead, I went and placed the function already in my calculator. I'm learning as I go how to make effective videos. Okay, so we type in x squared minus 3x minus 7 and we press graph. Okay, if we look at the x-intercepts, we see that we have approximately 4.5 and negative 1.5 as those x-intercepts. If I go back to our note sheet, what did we have? We had 4.5 and negative 1.5. So it comes full circle. So that is the final tool of how we work with solving quadratic equations. So we have 3 methods that we can use for solving quadratic equations. And in later lessons, we're going to go through these further in depth. But the first method that we can use is we can factor and then apply zero product property. However, we've learned that this does not always work because not every quadratic factors. So then the second method that we learned how to use is we learned that we could complete the square in order to then square root both sides to get an exact and an approximate answer. The third method that we just learned is the quadratic. Sorry, I'm struggling here. The quadratic formula. Now, I'm going to tell you guys that these 2 methods work in all cases. Okay, these 2 methods will work for every equation. So you might be saying, why did we just learn the quadratic formula if completing the square will work for every equation? Well, I'm here to say that when you have messy numbers or you have numbers in front of your x squared term, this is what you are going to want to turn to. Okay, so we saved the best for last. So now for the rest of this video, we are going to practice. So the video might get lengthy, but what I encourage you to do is put me on pause. You can fast forward if you're getting the hang of it, but you need to try to apply the formula to these 4 problems. Okay, practice makes perfect. Now what is the formula? X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you've got to get that in your head. So if I go ahead and do this first problem, I see that a is 3, b is 7, c is 2. So if I go ahead and apply the formula, x equals the opposite of 7 plus or minus the square root of, I'm going to put 7 in parentheses, square it, minus, it's always 4. My a is 3, my c is 2. All over 2 times a is 3. So the next step is to simplify under that square root. X equals negative 7 plus or minus the square root of 49, and then I'm going to always pair the negative with the 4. So negative 4 times 3 times 2. So negative 4 times 3 is negative 12. Negative 12 times 2 is negative 24. So in this case, we do have a negative. All over 2 times 3 is 6. Okay, from here, I still have to simplify under the square root. So x equals negative 7 plus or minus. We have 49 minus 24 equals 25. Ooh, I like that. You'll see why in a second. Over 6. Now, what can I do with the square root of 25? That is a perfect square number. So I am going to actually write 5 in place of the square root of 25. So in this case, we are not going to have exact and approximate answers. We're only going to have exact answers. So we can go ahead and make mini equations. And we can see that we are going to calculate x equals negative 7 plus 5 over 6 and x equals negative 7 minus 5 over 6. So we always do the numerator first. You have to. There's no choice. So -7 plus 5 is -2 over 6. And then -7 minus 5 is -12 over 6. Always simplify the fractions. So we see that our final answer is x equals -1/3 and x equals -2. Okay, so in this case, again, there are not approximate answers. These are exact because we were able to take the square root of 25 due to it being a perfect square number. Again, keep putting me on pause if you want to get practice of your own. If not, keep hanging with me. This is drill. So we have on part B, A is 2. Okay, B is -9, and C is -35. So let's apply the formula. X equals, the opposite of -9 is +9, plus or minus the square root of, put that B in parentheses, so -9, we're going to square it, minus 4 times 2 times -35. All of this right-hand side is over 2 times 2, because 2 is A. So we have x equals 9 plus or minus the square root of, we have -9 squared is 81. Remember, this first number will never, ever, ever be negative. And then I'm going to do -4 times 2 times -35, and that is positive 280, so I'm going to add 280. There's always going to be either a addition or a subtraction symbol there. It just depends on the sign of the numbers. And then I have 2 times 2 is 4. Continuing on, okay, I'm going to have x equals 9 plus or minus the square root, and I'm going to take 81 plus 280. You cannot square root those individually. You always have to add before you square root. So at this point, I'm going to see if I can square root 361, which, yay, I can. So we have 9 plus or minus the square root of 361 is 19. That is a perfect square number. So again, we're not going to have those exact and approximate answers. We're just going to have exact because we have our mini equations. We have x equals 9 plus 19 divided by 4, and we have x equals 9 minus 19 divided by 4. So now I can go ahead and do 9 plus 19, which is 28 over 4. And then I have 9 minus 19, which is -10 over 4. And then using my calculator, 28 over 4 is 7. Okay, and then I can reduce -10 over 4, but I do want to keep it as a fraction, -5 over 2. So these are my two solutions using the quadratic formula. Now, had you used completing the square, you would have gotten the same answers. And actually, fun fact, both of these two first problems would have factored, because when you get rational answers, that means that you could have used factoring with ZPP to solve. But sometimes the numbers get too large, so you don't even want to make the attempt. Two more. Keep going if you're getting the hang of it. Okay, we have A equals 8, we have B equals 10, and then we have C equals 3. So now we are going to apply the formula. X equals, what's the opposite of 10? -10, plus or minus the square root of, we have 10 quantity squared minus 4 times my A is 8, my C is 3, and then all of this is over 2 times 8. Let's simplify under the square root. 10, -10, plus or minus the square root. What's 10 squared? That's 100. And then I'm going to do -4 times 8 times 3. And I get -96, so I write -96 over 16. I have x equals -10 plus or minus the square root. 100 minus 96 is 4. Yay, that's a nice problem once again. So I'm going to see that because I can take the square root of 4, I'm going to have just my exact answers. I keep forgetting that negative on the 10. plus or minus, we no longer are going to have the square root. We have, what's the square root of 4? 2 over 16. So we have x equals negative 10 plus 2 over 16. And we have x equals negative 10 minus 2 over 16. Okay, one more step is we have, or I guess 2 more steps maybe, negative 10 plus 2 is negative 8 over 16, so that is going to reduce to negative 1/2. And then we have negative 10 minus 2 is negative 12 over 16, so we have x equals 3/4. You can use your calculator to simplify that. Negative 3/4, I should say, so please make sure that negative is still in there as well. Once again, that one would have factored because we are left with rational solutions. Let's see if this last one is messy or if it works out nicely again. Final problem. Thanks for sticking with me. Math is all about endurance. Okay, so we have A equals 1. We have B equals negative 5. And then C equals 9. I have x equals, what's the opposite of negative 5? Positive 5, plus or minus the square root. I'm putting that negative 5 in the parentheses before I square it, minus 4 times 1 times 9, all over 2 times 1. X equals 5 plus or minus the square root of negative 5 squared is 25 because the negative gets squared as well. When I do negative 4 times 1 times 9, I get negative 36 all over 2. Okay, so then I have x equals negative 5 plus or minus the square root. When I take 25 minus 36, I get negative 11 over 2. What is going on right here? I am taking the square root of a negative. Can I take a square root of a negative? No, I can't. That came up in the warm-up when we were working in perfect square form. So at this point, we see that the equation has no solution. So when you use the quadratic formula and you get to a roadblock, you don't have to turn to another approach. You can be certain that there are no solutions for that equation. Great job today. If these problems come up in your homework, keep chugging along with them. Please do view that video to memorize the square root song. You'll see in Google Classroom there is an extra credit opportunity if you want to send me your performance. But so long for today, and we will talk to you on the next lesson.